Hey everyone and welcome to the channel. Today we're going to create an out-of-body ghost effect. At this moment I'm half in the sun, half in the shade already, so I think we're good to go. The key topics are UV maps, uniform, mipmaps, and some frequently used built-in shader functions. This could be perfect for warlock spells, death animations, out-of-body transformations, or whatever your imagination can come up with. And the best part, we'll achieve all of this with just a few lines of shader and GDScript code. So here you see our One-Eyed Joe scene where our sprite is flying around. This scene consists of a 2D node, an animated sprite 2D, a camera 2D, and a simple glow sprite. That will be the shadow of the character. But today we will mostly focus on our animated sprite itself. So if we press on animated sprite, then already set up these animations for us. So we have a fly animation, the one you're seeing right now, and a die animation. We will not be using this one because we will mainly focus on the part where the ghost comes out of our character and vaporizes above it. One thing that is really important to note though is that all these sprites are separate PNGs. So it's very important that you do not use a sprite sheet with many sprites on it, but that you use separate image files, like you can see here in the file system. So for die we have 4 PNGs and for fly we have 8. And another thing you need to be aware of is that when you import them inside of the import panel over here, that you make sure that you generate mipmaps. This is very important later on. And if you forget to generate them, then you have to remove all the animated frames and re-add them once you imported the sprites again with the right configuration. So now we know what to do for our setup, let's move on to the actual shader. Alright, so press Scene and then make sure you select the animated sprite 2D. And because it is pixel art, we're going to use the filter nearest mipmap. This will make sure we get a nice pixel art effect. And then below it we see materials. Let's add a shader material and a new shader to it. For this it's very important to import it in the right folder, of course. So make sure you're in the right folder and then give it a descriptive name. In my case, I will give it the same name as our character and also our folder. Alright, once that's set up, let's press create. Press on the shader, open up the shader editor and remove the light and the vertex function because we're not going to need it. Be aware that the documentation of Godot states for the style guide that we use snake case for all the variable names within a shader. So let's stick to that. Alright, and now that everything is set up, let's get shading. So to start, let's give Joe a nice purple color. As a hint, it involves Swizzling. If you had no Swizzling idea what Swizzling even is, then bear with me. Swizzling makes it possible to obtain any combination of components in any order. So when we're talking about colors, we can simply specify the RGB colors in the reverse order, for example. Let me demonstrate what I mean by that. So we specify color and then RGB. This is the regular order we always use, but then we can read the color channels in a totally different order. So for example, if we want a green look, we can type color GRB like this. And if we now look at our Joe over here, we have a nice tint of green. I first want to mention a good way of following this video. I first show the code, then it's best for you to pause it, and then once you're done writing it on your own, then you continue the video again and you listen to my explanation. Because writing code and listening at the same time is not really great for your learning experience. Alright, that being said, time for you to create the purple look. Pause the video and have fun. Alright, so we will do it in a similar way, but this time let's store it in a variable. Let's store it in a vector3 variable and call it purple swizzle. And now we can select any order we want. So for purple we need green, blue and red, like this. And to write it to the color variable, we simply say color RGB equals sign and then purple swizzle. So basically what we did, we set the red color channel to the green color channel, which is of course not really green, but just a value between 0 and 1 that happened to be the green value of our original texture. Because we can also say YZX and then we will have exactly the same result. Y simply reads the second value of the color channel, the Z the third, and the X the first one. But let's set it back to GBR because when we work with colors, we should also specify colors. That makes more sense, don't you think? And the great thing about Swizzling is that we get to keep our very dark and our very light colors, which makes sure that the borders and the white areas, like our eyes, keep their original colors. Think about why this is. Pause the video and continue when you know. The reason for this is that the white bright colors represent values close to 1 and the dark black colors represent values close to 0. And because the dark and light parts must have a value close to those outer numbers on all the color channels, it simply does not matter if we swap the values of the existing color channels around. Black stays black and white stays white. Oh, and if during the videos you got any questions or you want more or maybe less detailed explanation, then always feel free to leave a comment below. Alright, and now that we have our color, let's start on the actual ghost. So for this effect, we basically need two textures, the original and the ghost-like texture. In reality though, we only have one texture. The second texture is just a second sample of that first texture. But without getting too much into the details, let's start writing the outline. So normally when you create complex shaders, it's a really good practice to create an outline for the effect you're going to make. So for this shader, I already prepared it for us. So first we start with sampling the color data from the vector4 variable, holding the normalized RGBA values of our Joe sprite. Simply put, this can be seen as the second texture that we use for our ghost. While in reality, we still only have one texture, we just sample it twice. Alright? And then we will see how to utilize UV mapping to move the texture upwards. Then we will create the uniform that holds the animation progress. And we can use it to slide it from left to right in the inspector panel to move from the beginning to the animation to the end. We can also use it later to animate it using GDScript. And then the last item for the first outline is that we give it the right color and opacity. Alright, for all the advanced shader wizards watching this video that already completed my course, please try to do this on your own. For everyone who is new to shaders, just sit back and enjoy the show and let me guide you through the shadows starting at the top of the list, which is sampling the color data. For this, we will need the built-in texture function. Please pause, copy the code, and then I'll explain it once you're done. So here we sample the color of our original texture for the second time. The first time is done automatically for us and is set to the color variable. The texture function can be seen as a function that searches through the color data of the original texture, which is stored in the texture sampler 2D. The texture function returns color data of the specific fragment that this function is running for. Because as you might know, the fragment function runs for every fragment inside of the texture. Once the texture function is done sampling the data, it returns it in the form of an RGBA value, which is a vector4 variable. If this goes too fast, then please watch the free episodes about how to set up your first shader. You can find it in the comment section below. Alright, let's see what we did. Let's write our ghost texture to the color variable. So let's say color equals ghost text. And text is mostly used as an abbreviation for texture. Great, see that we now have overwritten the purple colors we set at the top with the colors of the original texture. That's exactly what we were trying to do, so let's continue. So now that the first one is done, let's start on the second task, which involves UV mapping. Let's map the texture in a way that Joe over here moves upwards. Here is an example how it should look. If you think you can do it on your own, then please try. Alright, for this we need to sample the texture again, but this time with this small offset of our y-axis. UV mapping is a strange thing if you're new to it, but what you essentially do is deciding the area that you want to sample, and we strangely do this by mapping an area that is a bit lower than the original UV mapping area. So if we want to move Joe all the way to the top, then we should sample it right here. It's like making a screenshot and then placing that screenshot back into its frame. So let me show you what I mean. So let's say I make a screenshot like this. So that although I made a screenshot like here, and the original UV mapping area was over here, it resulted in that Joe is flying a bit higher than it did before. Alright, remember that in the coordinate system of Godot, the y-axis is reversed. So if the y-axis increases, our coordinate goes down. Now I have two options for you. So tell me, to move Joe up, should we add a value to the y-axis or should we subtract a value to the y-axis? As a hint, you have a 50% chance of having this right. Please pause the video and take your bet. And the answer is, we need to add a value. So this will be just right. And then let's remove this one. And now we see that Joe moved upwards. Cool, right? So what we did, we add to the y-axis, so the UV mapping area go down, and then we sample it, and like I showed before, it results in our texture moving up. The texture is still in the same bounds that it was before. We just sampled the color data to a different location inside of the texture. Alright, now that this is out of the way, let's move on to creating a uniform that will hold the animation progress. So at the top, let's add a uniform. Let's say uniform, float, and then say progress, like this. And let's also give it a hint range. And let's make sure it goes from 0 to 1. And if we now look in the inspector panel, we can nicely slide this slider from 0 to 1. Nothing happens because we didn't use the progress yet, but we will do that now. So now let's replace the hard-coded value inside of our fly up UV variable and change it with our uniform. So let's grab our progress uniform and add it over here. And if we now start sliding, we see it nicely moves up. But the downside is that it flies away. It moves out of the bounds of our texture. And that's not really what we want. So let's reduce the offset a bit. Alright, so we can divide it by 2, for example. And now it will still move a little bit out of the bounds, but it doesn't matter because we're going to make it transparent at the top anyway. So let's just leave it at 2. And now that's done, let's move to the final task of our first outline, which is giving it a grayscale color and some transparency. I will now stop asking you to pause the video and try it on your own, but every time that we are going to do a task of the outline, please just pause it, try to do it on your own, and then watch me do it. Because in the end, the best thing is to really understand how to write shaders. So in this series, I will show all kind of shaders, but eventually the goal is that you can create anything you like. So let's give Joe a grayscale color. To achieve this, we can simply swizzle the colors again. It's actually pretty easy. So we have to specify the texture of the ghost and then simply set its color channels all to the same channel. So let's use the red channel, for example. And then, of course, make sure you write it to the RGB values. Then we see we have a grayscale color. The reason why it becomes gray is that RGB colors use the additive color model, which can be thought of as colored light. When all 3 channels are equal, the light emitted or reflected is evenly balanced across all colors, resulting in a neutral tone. The human eye perceives this equal mix as a shade of gray, with the specific shade depending on the intensity of the values. So if we would change it to only blue channel, then we will have a different kind of gray. This one is way darker, and let's try green. This one is a bit in the middle. So I think only red is our best option anyway. But it's still a bit dark. So let's also brighten it up a bit. And of course we can do this by increasing the values, because the higher the value, the brighter the value. So let's just multiply this with 1.7, for example. This looks a lot better, don't you think? And now let's also make sure that we add a bit of transparency, and we can do that by specifying the texture again, this time the alpha channel, and then multiplying the alpha channel to 0.8. And then we see we get a bit of transparency. Of course, you can mix around with your own values, but I think this looks pretty good. Well done! We created the bulk of the effect already. Now let's get rid of the outlines and replace it with some clear comments. Once you're familiar with shaders and you fully understand them, then it's fine to only use descriptive variable names instead of actual comments. But because shaders might be new or you might not be writing them very often, it can be a good practice to write comments so you can easily see what's going on once you come back to them later. I speeded up a little bit for you. So here I created some comments. You can pause and write them also if you like. Alright, now let's figure out the final step that we need to create for our shader effect. Look at the effect and try to create the final steps of the outline yourself. pause the video and good luck. So at this point we only have our ghost. But what we actually want is seeing the original texture when the ghost process is 0 and show them both when the progress increases. For this we will use alpha compositioning. It's basically deciding what layer to show on top of what other layer. You might know this concept from the scene tree, for example. So what we want is setting the colors of the living Joe on top of the ghost of Joe. And a perfect way of doing this is using the mix function. Alright, so how the mix function works is when it is 1, it will return this part, and when it is 0, it will return this part. Here we see the effect. Remember, fragments with an alpha value of 1 are visible, and an alpha channel less than 1 will become partly or fully transparent. So to really understand how alpha compositioning works is by thinking of it as a mask. Imagine that we can only see the alpha channel. That will actually look like this. It's basically a mask. Dark colors representing transparency, which is close or equal to 0, and bright colors represent higher numbers, numbers close to 1, and makes the RGB colors visible on the screen. And if we now look at this mix function over here, then what we're actually doing is checking per fragment, because again, the fragment function runs for every single fragment. It checks if that specific fragment has an alpha channel on the original texture that is a bright color. So if it will be somewhere in that white area over here. And if it is, then show the original texture, because the alpha channel of the original texture will return a 1 in this case. And a 1 makes sure that this value is returned, which again are the colors and the alpha channel of the original texture, right? But if it's not inside of the area of the alpha channel of the original texture, then use the RGBA colors of the ghost texture. Let's turn the lights back on. So now that we know how it works, it also makes sense that when we now drag this progress, we see our ghost flying upwards. Cool, right? And good to know that it also interpolates between the two values. So let's say that the value of this one is not a 1, it's 0.5, then it will take half of the ghost texture and half of the original texture and mixes those two together. A nice but ugly example of this is when we would remove the filter and then zoom in a little bit. Then we see that the outer edges have a mixture between the ghost texture and the original texture, which results in a white outline. But we should not care about this because we're using nearest mipmap, which will automatically get rid of that anyway. Alright, another task is put to rest. Let's now move on to the fading out of our ghost, because we do not want it to be opaque all the way to the top, right? So let's do this task. And what we need to do for this is go to this line, because this of course already sets the transparency, but let's make sure we remove this magic number. So let's type float and let's say ghost opacity and let's set it to 0.8. Oh, for those who are not aware, a magical number means that you randomly just add a number without any description to it. So the next time that you come back, you're like, why did I fill in 0.8? And if you do that a lot of times in a big file, then you most likely get some headache reading it. So now that we give it a descriptive name, we can use it over here, and then we can subtract the same value, because if we do, then it's fully transparent, right? Because 0.8 minus 0.8 is 0, and that's what we want, because then it becomes transparent. And then we make sure that it depends on the ghost progress, like we have done before, like this. Alright, so if we now slide, we see that it nicely fades out. But of course, we can do better. Let's go to the next task, which is adding some blur to the animation. And this might sound complex, but luckily for us, it's pretty easy. At least the way I'm going to show you. For those who know what mipmaps are, that's what we're going to use. And for those who don't, I got a video about it in the description if you want to know more about it. So the way we will implement blur is by increasing the index of the mipmap from 0 to 4.5, which, as some may know, decreases the resolution of our texture a lot. And the way to take advantage of mipmaps is making sure that you import the image with mipmaps, then check the filter that it's set on a mipmap, either linear or nearest, and then not use a regular texture as function, but the texture lot. And then we got a third argument, and that's the one we need for setting the index. So for example, if we set it to 5, then we already see a nice blur, although it's not very obvious because our ghost is not visible. But let's set it to 2, for example. And now we see our blurred, pixelated, ghost-like figure over here. All right, so let's create a dedicated variable for it, and let's call it mipmap index equals, and then the ghost progress, and we multiply it with the index that we want to have when it reaches 1. So in this case, let's say we want an index of 4.5 when the progress is set to 1. And then of course also set it to the texture lot over here. And now it nicely fades out while it also blurs the texture. And now that that's done, we almost finished our animation. Now let's do a really quick cleanup, because it's better to only write to the color variable once. So instead of directly writing it, let's create a dedicated variable. Let's call it base Joe texture, like this. And then also make sure that the right side will be a vector 4. And for that, we need to add the alpha channel, and then simply use this one inside of the mix function over here. And if all went well, then we still have our nice effect. And that's already it. Now you can add the effect to an animation player or use a tween, for example, to animate it. If you want to use a tween, then here is how you set it up. When we now run our script, then we see it nicely fades out the ghost. So really all you need to do is run this code, and then the tween will make sure that our uniform is set for the duration of the amount of seconds that you want the tween to run. I hope you enjoyed creating this ghost shader with me as much as I did. If you found this tutorial helpful, then please give your thumbs up and consider subscribing to the channel for more content like this. For a deep dive into the world of 2D shaders, then please check out my 2D shader course on my website. The first part you can also find on Udemy. All the links can be found in the description below. That being said, stay away from the light, and until next time.